Okay, this is like the mother of all Doppler problems. So let's just solve this, right? So you're driving your car, and down the road, and here's this big old truck, big truck driving along, right? And they're going 17 meters per second, right? You're going 27 meters per second, which is why you're honking at them. I mean, you got to honk at the truck, right? And then, of course, and this is going to be just crazy, right? We're actually going to do four type of Doppler things, right? Okay. You're a moving source, so you're going to actually create a higher frequency in front of you, right? The back of the truck is going to observe that, right? So it's going to be source, higher frequency, right? Okay, they're going to observe that. That is, that in order to reflect off of it, this thing has to encounter those waves, right? So this is going to observe it, right, to a lower frequency, right? Then this becomes a source, right, to a lower frequency, right? And then as that reflection comes back off the truck, we're going to observe to a higher frequency, right? Okay. So we're going to do this, then we're going to do this. Doesn't matter what order you do them in, but this is what makes sense to me, right? And then 4. Right, so source, we're going to do source for higher, right? So it's going to be the shifted frequency is 1,000 times, let's see, this one has got the thing in the denominator, doesn't it? Okay, so 343 over 343, and then it's to a higher frequency, so it's minus the 27, right? Okay, so let's do that. 1,000 times 343 divided by parentheses, whoops. And then 343 minus 27. So that higher frequency in front is 1,085.44, right? Then, of course, the back of the truck's going to observe it, right? So that now becomes our frequency, right? Our shifted frequency is now 1,085.44, right, times 343. And this is going to go to a lower frequency because the truck is moving away from you, right? So minus 17 for the truck, right, divided by 343. So that times, parentheses, 43 minus 17 divided by 343. So that frequency is now 1,031.646 hertz, right? Okay, now this truck now is a source that's moving away from us, right? So the shifted frequency is 1,031.646, right, times, okay, so source is 343, and this is going to be to a lower frequency, so it's going to be 343 plus 17, right? Okay, so that times 343 divided by parentheses 343 plus 17. Ta-da! 982. 982.92. That's the frequency actually created. They're going this way, right? Of course, now we're going to drive into that frequency, right? We're going to be moving observers, so we are shifted frequency is the original frequency, 982.92, right? And then times 343, and then it's to a higher, right? So plus 27 over 343. This is finally going to be the answer. Okay, so times parentheses 343 plus 27 divided by, whoops, parentheses divided by 343. And I get 1,060.3. You're truly a dedicated student if you stayed with this thing the whole time, right? Okay, and then it's instructive to realize, okay, that's the answer there. If you did, there's all sorts of approximations you could do, but only that gets that exact right answer, right? If you if you said, okay, we're just going to use 10 meters per second, that's the difference, right? You get slightly a different answer, right? So let's say it's moving source, right? This is an approximate method, right? So 1,000 times 343 over 343 minus 10, right? 343 divided by parentheses 343 minus 10. You get 1,030 actually, right? So that doesn't work so well, right? And then if you do if you do the same thing and use the moving observer formula, right? If you use the moving formula, okay. If you use the moving source or moving observer run, then it's going to be 343 plus 10, right? Divided by 343. That doesn't work either. That gets you about 1,030, right? So anyway, yeah, you've got to do that whole thing that we just did.